Welcome to Xamarin University and IOS231, Customizing Maps on iOS. This class is a follow-up to IOS230, which is an introduction to iOS mapping, where we learned how to display a map in iOS and show a simple annotation. Today we're going to learn how to customize the annotations displayed in an MK map view, and respond to user interactions, search for points of interest, and show directions. We have a lot of ground to cover today, so let's get started. We'll start by exploring how to customize the appearance of our annotations. To do this, we're going to learn how to use a map delegate protocol, which can be used to receive and respond to map-related update messages. Then, we'll explore several techniques for controlling the visualization of our annotations. Remember from iOS 230, the MK annotation is the base class that we'll use to manage the data for our location on the map. The MK point annotation class is a specific implementation of that class that stores the title and the position for our location. And again, remember, these classes are essentially the models for our points of interest. The visualization base class is MK annotation view, and the default visualization, that is, the visualization that shows a marker on the map, is a specific implementation of MK annotation view. And that's called the MK marker annotation view. We'll be using and customizing these classes. Now let's talk about customizing the MK map view. We have two possible approaches. First, the MK map view class exposes public event properties which can be used to respond to map notifications. This allows us to respond to user input, map viewport changes, or control the visualization for annotations displayed on the map. Alternatively, we can use a map view delegate class. MK map view delegate is a protocol. It's implemented as a class in C#, and we can use this to respond to those same update notifications on the map. Again, this includes responding to map positional changes, managing annotation views, and tracking the user location. This is an optional implementation, as you saw in the previous class. It's not required when you're using an MK map view, and without implementing a map view delegate, the map will simply use the default visualizations and behavior. The map view delegate is useful for separating map-specific behavior from the view controller, and it's very useful if you're displaying maps with similar characteristics in more than one location in your application. It's also the way that Objective-C and Swift developers will customize their maps. So if you're porting code from Apple samples, you'll see a map delegate. However, you have the exact same customization options using either the event properties or the delegate, and C# developers will often prefer using event properties. Just remember, you can't use both approaches on the same MK map view instance. You can use the delegate or the event properties, but not both. To add a map delegate class, we'll start by creating a new class that derives from MK map view delegate. We can then optionally override methods to respond to behavior or control visualization. And there's a large selection of method overrides available. It provides a lot of flexibility in responding to user interactions and controlling the visualization for most aspects of the map. To assign a delegate class to a map, instantiate your MKMapView delegate derived class and assign it to the delegate property of your MKMapView instance. One of the most common uses for a map delegate is to control the appearance of the map annotations. To do this, override the getViewForAnnotation method. This method receives both a reference to the MKMapView and a reference to the annotation to be visualized as an abstraction. As you can see here on the slide, it's passed in as an IMKAnnotation interface. You then would return an MKAnnotationView derived object to define the visualization. In this slide, we're creating an MKMarkerAnnotationView. If you return null, the default red pin will be displayed. Now that we're creating the views, let's talk about how to customize them. The default annotation view is an MKMarkerAnnotationView. This view displays a red marker representing the location on the map. MKMarkerAnnotationView has a property called MarkerTintColor that allows you to change the color of the marker to any UI color value. MKMarkerAnnotationView was designed to allow basic customization of the marker's content. The glyph text allows you to assign a string to the contents of the marker. And you can change the image of the marker by changing the glyph image property. You can also display a different marker image if the annotation has been selected by using the selected glyph image property. When it comes to applying visual styles to annotations, it's important to think about how our location annotations are defined. Again, remember we use two related classes. The MK annotation holds the data for our location, and the MK annotation view defines the appearance. Both of these objects can be customized to control visualization and convey information to the user. Very often, you'll want to associate specific data with a location on the map. The default MK Annotation class stores a location, a title, and a subtitle. You can create custom classes that derive from MK Annotation, and then add additional fields, properties, and methods to store related information, or even perform calculations based on the provided data. We can add custom annotations to the map just like we would if we were using the default MK Pin annotation type. Instantiate your custom annotation and add it to the map using the add annotation method. Notice that no cast was necessary. On the previous slide, we saw that our class derived from MK Annotation, which implements the IMK Annotation interface, which is exactly what the add annotation method is expecting. We can access our custom data when we're working with annotations in our map view delegate or event properties. For example, in the getViewForAnnotation method, we receive the annotation as an IMK annotation. Here, you'll want to cast it to your specific type, which will then make any public properties or methods available. In this example, we're changing the pin color based on the house price, which is a property on our custom annotation class. You'll get a chance to try this in the next exercise. So it's time for the very first exercise. Open up the worksheet that comes along with the lab exercises for this class. Start with exercise 1, pause this video, and come back when you're done. We're not limited to only using Apple's default pin image. We can also display custom images or views to represent our annotations. To use custom images, we have two possible approaches. First, we can use the MK Annotation View class, which can display any UI image. If you're displaying unique images or data per annotation, you'll likely want to create a custom class that derives from MK Annotation View. This is really an architectural choice. If the logic to display your custom visuals is more than just a few lines of code, subclassing the MK Annotation View will likely be the better choice. To replace the default pin with a custom image, you're again going to use the getViewForAnnotation method. Instead of newing up an MK Marker View annotation like you did previously, you'll instantiate instances of the MK Annotation View class and set its image property to a UI image. By default, iOS aligns annotations to the center of the view. You can adjust the point of view location in relation to your image by setting the center offset property on the MK Annotation View. In this example, we're moving the center position 20 points in the Y direction. Now, when the map renders the annotation, the bottom center of the image will correctly align with our point of interest on the map. Let's look at an example of when you would subclass the MK Annotation View. This code snippet is using a UI label to display pricing information on the annotation. There's also a stub method called onTapped that can be used to define behavior when the annotation has been tapped. Now, although this code could be placed all within the map view delegate, it's complex enough that it should be separated out into its own class. For either approach, there's an important optimization you should always perform when creating annotation views. When annotations are moved off screen, for example when the user pans the map, they're not automatically destroyed. They're placed in a queue to be reused when new annotations are to be displayed on the map. Rather than always instantiating new views, call the DQReusable annotation method on the map view. This allows iOS to return existing annotation views instead of always creating new view objects. iOS knows which view you need through a string reuse identifier. This means you can create multiple annotation styles on the same map, but you'll need to identify each style using a unique reuse ID. When using recycled pins, you'll need to update the annotation, or the model data, for the visualization. Notice that the annotation is passed into the constructor when creating a new MK Annotation View. When a view is reused, the previous data will still be present. Make sure to update the annotation property with the correct annotation. Now it's time for your second exercise to create a custom annotation. Open up the worksheet, complete this exercise, and then come back to this video. In this section, we learned about the map delegate protocol, and we saw several techniques we can use to control the appearance of our annotations. We're now going to look at how we can make our map view more clear by grouping overlapping annotations into clusters. To do this, we're first going to look at a simple API to enable cluster support. Then we will use the MK marker annotation view because it has built-in support for clustering. As you add more and more annotations, they'll begin to overlap and look cluttered. This makes it challenging for your users to read and understand what's going on. However, luckily for us, iOS has a solution. In iOS 11 and above, Apple added support for clustering. Clustering allows us to group annotations that are overlapping into a single new annotation. The new clustering annotation can be a built-in annotation or a custom annotation. MK-MapView determines when cluster annotations are created by using hit testing. If at least two annotations are touching, they're eligible to be grouped into a cluster. In this group, since there are 3 annotations touching, this could be turned into a cluster of 3. And this group has 2 annotations touching, which could turn into a cluster of 2. Zoom level is also a factor in determining a cluster. As you zoom out, the map gets smaller and causes the annotations to get closer. For example, in the left image, the 2 annotations are not touching. However, in the right image, by zooming out, they're now touching and eligible for clustering. Annotations should only be clustered together when they relate. For example, in this image, there's an annotation for a grocery store and a movie theater. Since the movie theater doesn't relate to the grocery store, a cluster shouldn't be created. The cluster identifier is a string that represents which annotations should be grouped together. If 2 annotations have the same cluster identifier and they are overlapping, then they are eligible to be clustered together. Here, the 2 grocery store annotations are eligible to be clustered because they are overlapping and they have the same cluster identifier. However, the movie theater annotation will not be clustered with the grocery stores because they have a different cluster identifier. Supporting clustering is as easy as assigning a string to the annotation view's clustering identifier property. Setting the cluster identifier actually has 2 effects. First, it enables automatic clustering support. Second, it sets the cluster identifier that will be used to detect which other annotations it should cluster with. Now, as I said before, you can use a custom or a built-in annotation view to represent the cluster annotation. However, the built-in MK marker annotation view has direct support for clustering and will automatically include the number of replaced annotations. Now, go back to the worksheet and work on the next exercise to enable clustering support in your application. Pause this video and come back when you're done. In this section, we looked at how we could make our map views more organized by adding clustering support. Next, let's explore how to respond to user interactions. First, we're going to enable and customize the callout displayed when a user taps on an annotation, and then we'll detect and respond to taps on the callout itself. The annotation view isn't our only point of customization. We can also customize the callout that appears when an annotation is tapped. By default, when adding an annotation to a map, it will display a callout when the user taps on that annotation. When overriding the get view for annotation in the map view delegate, the callout must be explicitly enabled by setting its canShowCallout property to true. The callout by default will show the annotation title and subtitle. If you want to show more than just these 2 pieces of textual information, or you want to respond to user taps, some customization is required. The callout has 2 properties that can be used to add views to the callout. Left callout accessory view will be displayed to the left of the title and subtitle. Right callout accessory view appears to the right. These 2 properties are of type UI view, meaning we can display almost any UI view of reasonable size on the callout. As an example, here we're setting a UI image view on the left callout accessory and a detailed disclosure button on the right. To respond to user taps on the callout, another method override is required. Override the callout accessory control tapped method in the map view delegate. Notice that the annotation view that the user has tapped is passed in as an argument. You can reach the model data, the annotation, by using the annotation property on the view. Now note, this method will only be called if a button has been added to one of the accessory views on the callout. Also, we can respond to taps directly on a map annotation. This time, in the map view delegate, we override the didSelectAnnotationView method. Notice this method also passes in the annotation view, which again allows us to reach the annotation data through its annotation property. And now, go back to your worksheet, work on the next exercise, which is add behavior to the annotations. Pause this video and come back when that is complete. And now let's talk about how to search for points of interest using the mapping APIs. MKMapKit also includes APIs to search for addresses and points of interest that are exposed through the MKLocalSearch class. The searches are performed on Apple servers, meaning an active internet connection is required. Although the search responses are often displayed as annotations on a map, that's not actually a requirement. Search and the search results can be used in applications that don't display a map. MapKit supports searching for points of interest using a user-entered natural language query. Optionally, searches can be constrained to a specific geographic region. We use an MKLocalSearchRequest object to define the search, and it has two properties. Natural language query is used to set the natural language search term or phrase as a string, for example, coffee or gas station or grocery store. The region property can also be set to constrain the search to a specified area. To perform the search, instantiate an MKLocalSearch object, pass in the search request object as a constructor parameter, and then call the startAsync method. The startAsync method returns a task and should be awaited. The search results are exposed as an MKLocalSearch response object. The response contains a property called mapItems, which contains exactly what it sounds like, a list of map items. The mapItem object contains the detailed information about each search result location. The MKMapItem object contains the name, the location, and the website URL for each search result. It also has a PlaceMark property, which contains additional geographic information. Let's take a closer look at the PlaceMark. The PlaceMark property holds an MKPlaceMark object. The PlaceMark stores information about the location, including the address, the region, the country code, the time zone, the latitude and longitude. And we're going to use that in this next exercise. Go back to your worksheet, open the next exercise, which is searching for points of interest. Complete that exercise, and then come back to this video. So there we saw how we can perform a search for points of interest and display those results on the map. In our final objective, we're going to learn how to add another visual element to the map that's known as an overlay. We'll start by exploring the types of overlays available before walking through the specific steps required to add an overlay to the map. And finally, we'll see how to calculate directions between two locations and then visualize the route. So the MKMap view is able to display another type of annotation. It's known as an overlay. There are three types of overlays that we can add to a map. There's circles, which represent a location with a given radius. That's typically used to highlight a specific location. Polygons can create a closed shape around three or more locations. Typically, that's used to highlight a region on the map. And then polylines are similar to polygons. So a line is drawn between points in the order that they're provided, and that's often used to show directions. Additionally, custom overlays can be created to show arbitrary geometries with granular customized drawing code. For example, weather radar would be a good candidate for a custom overlay. Programmatically, we work with overlays through an abstraction. IMKOverlay exposes the MKOverlay protocol, which defines our map overlays. There are concrete IMKOverlay implementations, one for each type of overlay. There's an MK circle, MK polygon, and MK polyline. We create overlays through static factory methods exposed on each concrete IMK overlay object. As an example, we see the MK polygon from coordinates method. It accepts a collection of CL location coordinate 2D objects. The created overlay object is then passed into the map's add overlay method. Here we see another example, creating a circle overlay with a center coordinate and a radius, which is in meters. It's then added to the MKMapView instance through the add overlay method. Overlays are displayed using two interrelated classes. The first we've already seen, which is the MK overlay that describes the data. You can think of this as the model. And that's what's added to the MK map view. The second, though, is a renderer, which describes how the overlay should be drawn. There's a specific renderer for each of the 3 overlay types: MK Circle Renderer, MK Polygon Renderer, and MK Polyline Renderer. To make an overlay visible on the map, override the Overlay Renderer method in the map view delegate. Then check the type of the passed-in IMK overlay interface. You'll need to create a renderer to match the overlay type. In the code that you see here, we create an MK Circle renderer, we set its fill color, and then we return. If no renderer is returned, then the overlay will not be visible on the map. The renderer is derived from the MK Overlay Path Renderer class, and this base class exposes properties that are used to customize the appearance of the overlays. This includes the fill color, stroke color, and line width properties. There are also less commonly used properties that can be used to adjust how lines are rendered, for example displaying solid or dashed lines, or smoothing out connecting line segments. As mentioned earlier, an MK polyline is an excellent way to represent directions or route between 2 locations on a map. We can retrieve turn-by-turn instructions to display on a map using the MK Directions API. The first step in calculating directions is to create an MK Directions request object. This object has 3 properties. The source is an MK map item that represents the starting location. Destination is another MK map item representing the final destination. Request alternate routes controls whether the APIs will return additional alternate routes in the response. To search for directions from Apple servers, create an MK Directions object, passing in an MK Directions request object to the constructor, and use the calculate directions method to begin the search. Notice here, the syntax is different than searching for locations. This method is not a task-based asynchronous method. Instead, it takes an async delegate method, which will receive the directions. The directions are passed to the delegate as an MK Directions response object. The direction routes are exposed on the response's routes property as a collection of MK route objects. An MK route object defines a single route between 2 locations. It contains a number of useful properties that provide information like estimated travel time and any travel advisory notices along the route. It also contains a polyline property, which can be added directly to the map as an overlay. For our final exercise, go back to your worksheet and you will add overlays and display directions on the map. Pause this video and come back when you are done. So now we've seen how to add overlays on top of the map to highlight specific regions. Thank you for watching our video from Xamarin University on iOS mapping.